So in this video, we'll start talking about classes, which is part of object-oriented programming. The same way functions group together blocks of code that do some operations, classes are also entities that group together statements that perform operations. Now, the difference here is that classes are templates that describe behaviors and states that the objects will have. So, classes are used to create objects which in many languages, especially in Swift, they are simply a representation of a real-world object. So classes are the blueprint of objects, and these entities are the building blocks of objects and object-oriented programming. For example, in the real world, we have, for instance, a ball. This could be a basketball, a soccer ball, or even a football, right? American football, of course. All right. So now this ball here has properties. This ball could have color red, size, and so forth. Those are properties of this ball. Also, this ball has behaviors. So this ball can bounce, can inflate, deflate, and do a lot of things. So as you can see here, we can actually represent a real ball in terms of code by creating classes, which then we can instantiate, we can create objects out of it. One important thing I need you to understand when you think of classes and object is that think of a class as a cookie cutter. You use a cookie cutter to cut shapes of cookies, which then you can create a lot of different cookies, all of them from one cookie cutter. Now, the object in this case would be then the actual cookie, because you've used the cookie cutter as this blueprint to create shapes of different cookies. Let's go ahead then and take a look at how to create classes, which in return create objects. All right, let's take a look. So I went ahead and created a classes project, a playground project. So go ahead and do that. So go ahead and create a classes project. It has to be a playground project. All right. How do we create classes in Swift? We go ahead and say class, that's the keyword, and Swift is kind enough to give us a hint as to what we need to create a class. So as you can see, there's class, and then we have to add a name. So the name, let's call this ball. All right. So here we go. We have our class. We name it ball, and notice we don't have the parentheses here after ball. Instead, we actually have braces. Now, in our little presentation, we talk about class as this entity that holds properties, and it also holds behaviors. If you think of a real-world ball, a ball will have color, size, and many other properties. But for now, let's just use those two properties. So we're going to go ahead and say var color. We want it to be of type string and say enter. And we notice we're going to have an issue right away. If you click here to this red here, it says fix. Class ball has no initializers. So this is a good time. Let's go ahead and fix it. Just go say enter. This is a good time to talk about initializers. Later, we will actually create initializers for our classes. So it turns out in Swift, every variable you create, it has to be initialized. So as you can see, we can't just say var color of type string and nothing there. We have to actually say explicitly that is empty, or if it's an integer, we put 0 or nil or something. So we have to initialize them. If you try to do otherwise, you will get an error, which is good, and then Swift always reminds us. So that's our first property. Our second, we're going to say var size, and it's going to be of type int. Enter. Let's initialize it to 0. So these two here are our properties of our ball class. So behaviors is anything our object does. So a ball can deflate, can inflate, and also a ball can bounce. So those are behaviors of what a ball does. Now, if we talk about behaviors and we talk about what this item does, you can right away infer that we could also say the way we represent behavior in our code here would be via function. So we can create a function here, say func. We've done this, and we're going to say bounce. And of course, it's a function, we have to close there. All right. And let's go ahead and make it return a string. And here, what we can do, we can go ahead and say return a string that say I bounce. Perfect. Okay. So now remember here, this class here, ball, It's just a cookie cutter. It's a template. It's a blueprint. It's not necessarily an object we can actually use and do useful things with it. So it's an entity that on its own makes sense. A ball has, properties, so in this case, color and size, and has behavior. It bounces. Now, how do we then create an instance, an actual object off of this ball here? Simply here, instance of class var, because we have to assign a variable. I'm going to call it my ball is equal, then I just say ball and close parentheses. What's happening here? I'm instantiating my ball of type ball. So essentially I'm just creating a ball in memory using this blueprint here. Okay, now that I have my ball here, an actual object instantiated, what I can do now, I can access properties and the behaviors. Okay, I could go ahead and say my ball dot size is equal to, I can give it a size, I know it's an integer, I can say 12. All right, I can go ahead and say my ball again, and you notice the moment I say my ball, the system already knows that you're talking about this my ball here, which is of type ball, is the actual object from ball class. Okay, so enter. Then let's access the color. Let's give it blue. Let's print something. Let's say print and say here's my ball. And then let's pass the values. Let's say my ball dot size and my ball dot color. Notice what happens. Here's my ball, 12 and blue. Because what we did, we set my ball size, my ball property size to be 12 and the color to be blue. All right. If we then wanted to access our bounce behavior here, we call this, by the way, an instance method because it is included inside of our class here. So in order to access that, we can go ahead and say print and let's append and say my ball dot bounce. Close that and I bounce. So it's returning I bounce behavior. Okay, or rather let's say bouncing because that's correct, right? Like that. And I am bouncing. Now the beauty of this, because we talked about cookie cutter, we talked about creating a lot of different cookies with just one cookie cutter, in this case our class here, ball, I can create as many balls as I want. I could go ahead here, if I want, I can say var, let's call this basket ball, and create an instance of it. So I say ball, right? Now I have a basketball, which has all of these properties and behavior. And then I can go ahead and start setting up properties for basketball only. Say basketball dot color is equal, say red, okay? I can also say basketball dot size, let's say 23. Of course, these sizes are not accurate at all. And I can go ahead and print basketball, and I can say basketball dot color, okay, and basketball dot size, and you can see basketball red and 23. It's showing here to the right. Create here, say soccer ball is equal ball, right? And do the same. Say soccer size. Let's say 10. Okay. Soccer ball dot color. Give it a white. And let me copy this and do the same here. Print. Copy this and just there. And you can see basketball white and 10. This is object-oriented programming because we created here our class, and then we can instantiate as many times as we need to and create different instances of ball. And of course, in behaviors, we can put as many behaviors as we want, as well as on properties here. So this is just an example to show you how to create classes and how to use those classes to then create objects. And you notice right away this dot notation here. We've seen this before, where when we were creating our iOS projects, you notice that Xcode already brings a lot of classes and objects for us to use. Because you remember, for instance, we talked about the UI color. For instance, if you just type here UI color, as you can see, this is a class. You can see, says C here, it's a class. So somebody had to create this class here, just like what we did here. There's no difference. And added instance variables or properties and added behaviors and so forth. Okay, you can see here, UI collection view update item is a class and many, many others. I hope you start seeing the power of object-oriented programming here, because it allows us to have a lot more flexibility on creating objects and classes that create objects which we can use in our programs. And it makes our code much more readable, more efficient, and more usable. And extensible, so we can then extend things, use classes that somebody wrote, such as, UI color. That way we don't have to recreate the same class. We can just use the same class and get the job done. Okay, so, this concept here may be a little bit strange at first. I hope I was able to give you the basics of how to create a class and how to, from classes, how then to create objects, in which case we did here. Understanding the whole point of having to go through this process of creating classes and all of that. And of course, this will become more apparent as we go through this course, but now you have a solid introduction to object-oriented programming. And I would like you to go ahead and reread this code here, write yourself and create different classes, add more properties and more behaviors, so you can start seeing on your own how all of this stuff works. It's really, really important. All right? Okay. Well, I'll see you in the next video.